Assalamualaikum. My name is Abdul Hadi Izlan Mizamri. Nama matrix AA180862 and we are from group 45.
Assalamualaikum. My name is Muhammad Lukman Hakim bin Zainuddin. My matric number AA181919 and I'm from group 045.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alifani bin Rosmat. My metric numbers is AA181793. Okay. Today I'm gonna present you about the objective of the project. The first objective is to generate electrical power supply by using dry cell. The second one is to create automatic temperature control system technology. And the third one is to generate energy by using non-renewable energy to renewable energy. And the project scope is the battery is used to produce an electricity to the box, and the microcontroller uses the sensor to control the bulbs or the heat that made from the box. And the third one is the project can generate electrical power by using battery, same as using gas to warm food. Okay, that's all from me. Thank you.
I will talk about the introduction of this project. A typical tudung saji is a dietary cover that the Malays also use to cover their food. Usage of tudung saji is now used to avoid feed from rat and flies. Yet, unfortunately, it cannot hold the food temperature. The consistency in theory nourishment must always be dry. To guarantee the freshness of the food is great, the temperature must be kept around the food. Based on this question, an ideal for developing a control device temperature control technology for replace classic tudung saji. Based on the question, the idea of creating an automatic temperature control system that applied to traditional system tudung saji to become more creative, competitive and productive helpful. These paper sets forth a new clever idea tudung saji suitable for different application. It does have an automatic service with microcontroller Arduino, have a special style such as 2 diode light emitting, which is LED bulbs, and 2 catches. This is about improving the function to be more reliable and efficient way of holding food temperature are always hot. This project sets out a comfort, simple to use and realistic for human life, particularly for women with carriers. It also certainly helps maintain freshness and consistency of the food. Finally, this project will save power where only it operates when food temperature is below 60 Celsius.
For the methodology, the application that we use in this project is Arduino Uno Atmega 328P microcontroller, sensor LM35 and Proteus light. For the block diagram, the input is temperature sensor LM35. The controller is microcontroller Atmega 328P, and for the output is heating element, which is we use 2 bulbs. Process, it starts with for the results. The result of these projects are divided into 2 parts, which are the software simulation and actual hardware. In software simulation, the automatic temperature control system for smart food warmer can function according to the algorithm. As you can see in the circuit diagram in Proteus simulation, when the DC battery supply is turned on, the circuit can start operate. Then the sensor LM35 can start the function to measure the change of the temperature surrounds in the area. The Atmega 328P is the main component of the circuits. All the operations are controlled by this component to produce the output. It shows that the bulbs will turn off when the sensor LM35 detects the temperature reach 60 Celsius. When the temperature is down below 35 Celsius, the bulbs will turn on back until it reach 60 Celsius. For the coding in this programming, we declare the sensor pin equals to A0, and the second we declare the sensor value equals to 0, and we declare the lamp equals to 4. The void setup serial begin is 6900 pin mode sensor pin input. For white load, sensor value equals to analog read sensor pin. Serial print sensor value, serial print sensor value. Serial print delay for 500 seconds. If sensor value is larger than 60, the lamp will low and delay for 100 seconds. As if sensor value below 35 Celsius, digital bright lamp is high and it delay for 10,000 seconds.
Okay, this is the conclusion of this project. In conclusion, the development of this innovative smart food warmer is successfully done. The hardware implementation together with its operation work accordingly as stated in the procedure. The circuit is quite simple but efficient with high consistency. This project has fulfilled the main objective, which prevent the food from the bacteria and maintain the temperature of the food by using the temperature sensor LM35 to cut off the power if the temperature is higher than 60 Celsius. So, it can save more electricity than using the high technology devices. In the future, there are several improvements that can be made in order to upgrade the features of this food warmer to be something more extraordinary and modern by the time. For example, it can replace it with using an aluminium foil that can be more producing heat energy from the sources of the bulb. Okay, thank you.